Let's begin now.
Hey guys, and welcome back. So today we are going to be looking at percentage yield. Now, percentage yield tells us how efficient a reaction is. Now, why it is important to know this is because it reduces the amount of expensive chemicals that you use, and it also reduces waste. Now, the calculation goes as follows. Percentage yield is equal to the actual yield divided by the theoretical yield multiply with 100. Now, by actual yield in this case is the amount of product that you measure, like with a scale, and the theoretical yield is the amount of product that you calculate. So if I was in the industry and I was now making fertilizer, for example, like in my previous example, then what would happen is I would do my calculation, see how much fertilizer I should be producing, just like we did with the example. I think it was 2,600, something like that, grams. So that was my theoretical yield. And now I actually go and do it. I go and take my sulfuric acid, I go and take my ammonia, put it together, have them react, and then I go and weigh the amount of product that is formed, which is, of course, ammonium sulfate. And when I weigh it, I'm going to find that there is a difference between that which I was supposed to get and how much I actually got. And it's obviously less. I got less than I was supposed to get. So, why does this happen? Well, certain reactions aren't as effective as other reactions. So, the key thing is now there's a couple of reasons for this, which we'll get into at a later stage. But the key thing is to find a reaction that is as effective as possible. And that is why it is important to determine the percentage yield. Now, percentage yield is just kind of like a little add on the previous lesson where we were able to determine the limiting reagent. And based on the limiting reagent, we determined the amount of product that was formed. And then this amount of product will be my theoretical yield. Okay, so my actual yield is then just basically what they tell me. So that's the add-on to the previous lesson. So let's quickly look at the example. Now this example carries on from our previous example where we had sulfuric acid that reacts with ammonia to produce the fertilizer ammonium sulfate according to the following equation. All right, so that is the same equation that we were using. Now it does, however, the question differs where it says a factory worker carries out the above reaction. Again, it says using 2 kilograms of sulfuric acid and 1 kilogram of ammonia. And then this is what they tell us. They get 2.5 kilograms of ammonium sulfate. So now they want to know what is the percentage yield of the reaction. Now, when you are to get a question like this, you'll find that firstly, you'll have to determine the limiting reagent, then you'll have to determine how much product, and then you can do the step where we can determine the percentage yield. But since we've already done the previous steps for this specific question, we can just continue on determining the percentage yield. Theoretical yield was equal to, and there it is, 2,694.12 grams. So it was 2,694.12 grams. All right. My actual yield is what they gave us in our question. So they said we got, so actual yield was equal to 2.5 kilogram. All right. Now, as you can see, we're working here with different units, so we just have to make sure that we choose one unit and work with that. Because we're working with percentage, in this case, like literally we're just calculating the percentage. It's not crucial to go with grams, all right? So let's not go with grams so that we know when in doubt, go with grams. All right. So that would then be times 1,000 gives us 2,500 grams. Okay, so our equation, sorry, our formula, there we go. Our formula is percentage yield is equal to actual yield. Remember, it's the small divided by the big. Actual yield divided by theoretical yield. And then because it's percentage, we have to multiply it with 100. So now we just substitute. So my actual yield, and that is the one they give us. Obviously, we can't go into the factory and determine this for ourselves, so they have to give this in the question. So it's 2,500 divided by, divided by 2,694, 12 times 100. So now we pop that into our calculator. So we have 2,500 divided by 2694.12 multiply with 100, and that gives us 92,80, right? We're rounding it off. Well, no, we can leave it as 9. So it's 92,79. See, because that's a 4. So my answer is 92,79%. This is not a too bad percentage yield. Right. So again, this is just a little add-on to the previous question, or whenever they ask you for percentage yield, you need to know the theoretical yield, so you'll just have to calculate that. Remember, when you calculate that, to check if you do know the amount of moles that you have to work with of your reactants, the amount of moles of your reactants. And also, when you do this, make sure that you know, so it's the limiting reagent and then also your theoretical yield. Okay guys, so just do exercise 8-4 and I'll put the corrections on at the end.
Big addition, not gonna